Hello, everyone, and welcome to our Black Tides training event. We are Black in technology, informatics, data science, epidemiology, and social science. Our 2023-24 Executive Committee consists of Kimberly Dees, who is our informatics and LinkedIn lead, Sia Seiko, who is our strategic operations, Twitter lead, and communications lead, Andrea Hobby, who is our epidemiology lead, Lauren Shores, who is our mentoring and networking lead, Hannah Hanfi, who is our statistics lead, and Natasha Wooten, who is our graphic designs lead. Thank you for attending. We hope you enjoy today's presentation.
For Black Ties. And obviously, we aim to support and develop Black professionals in the data space. Thank you all for joining tonight. So today I'm going to be talking about a personal project that I worked on using geospatial analysis in Python. And in particular, I was looking at Chicago data. I'm from Chicago, love my city. And this project was basically an attempt for me to dig into the possibility of building a tool that would help me figure out where I would want to live in the city of Chicago. So this presentation is of the first installment of that project and eventually leading up to building that tool. And I wanted to basically share with you all kind of the power of geospatial analysis, being able to combine spatial data with characteristics and how much more insights you can get from kind of seeing your data in a spatial context. So this is the agenda for today. First, I'm going to give you some high-level insights that I got from doing my analysis. And then I am going to walk you through quickly what geospatial is, and then what GeoPandas is, which is a package in Python for geospatial. And then we'll switch over to my Jupyter notebook and walk through the code so that you can kind of see how we combine the data, how can we visualize spatial data, and the approach kind of that I took to developing the insights.
Lauren, sorry to interrupt you real quick. We have a question here. Okay. Would people be able to follow along if they have notebooks?
I do have this in a GitHub repo, but I don't think I committed the latest, so it probably is out of sync. But I can definitely share the repo afterwards when I update it, so that if you want to go back to the code, you can do it and take a look, use the code, whatever you want to do.
And let me just add real quick that the data and code for all of our workshops will be available on our GitHub site. I'm going to find it real quick and drop a link for everyone. Okay. So we'll put it in there in the next couple of days, but we actually already have a few from our prior workshops. We already have the data and code for those in case you want to check those out. So I'm going to find the link and then I'll drop it in the chat for everyone. Thank you.
Thanks, Sia. Okay, so insights from the data, location. When I'm thinking about where I want to live, personally, I look at three particular things. Is it safe? Can I get around easily without a car? Because I'm a city girl and I don't like driving. And is there a lot of options for food and to go out close to me? So basically the insights that I want to be looking into are around those three main points. And the map that you see on this slide here is an example of the types of maps that you can create using pandas and merging your data together. So I'm not going to go into detail about this particular map, but just notice here that it's of Chicago. The points on the map are actually CTA, so that's our public transit system for our trains, our metro. There's CTA stations, and the community areas on this map are colored by a particular characteristic, say, number of crimes, or this isn't that, but for example. All right. So kind of the key takeaways that I got from just digging into some of the data is crimes are more likely to happen in certain parts of the city. Like, we all can figure that. We all know some parts are dangerous than others. However, some interesting things I found about Chicago is that thefts happen more so downtown and in areas where there are more restaurants and bars, which I guess makes sense. And then violent types of crimes are happen more so on the south and west sides of the city, with some neighborhoods being way more dangerous than others. And also, I saw that some parts of the city may be more heavily policed than others. And I kind of drew this conclusion from looking at arrest rates versus the crimes that happen. Now, obviously, that's a point that you want to dig into more with data, but just by quickly looking at these two different data points, we can see that some neighborhoods, such as on the north side, they are in the bottom of group for numbers of violent crimes, but at the top for arrest rates. And then transportation and funds. So the CTA coverage, when you look at it spatially, it's obvious to see that there's more coverage on the north side of the city for public transportation than on the south side. And the CTA actually extends out of the city of Chicago more so to the north side and doesn't even reach the bottom of the south part of the city. So that's interesting. And yeah, the north side has way more options for restaurants, bars, and cafes. So what is geospatial data? So it's any data that includes information or describes something based on its location on the earth. And there's two different types of representations of spatial data. First one being vector data, which is what we'll be looking at and is used a lot more commonly. Applications like Google Maps and Apple Maps and stuff, they use vector data, vector representations. And raster data, which is represented by a grid. And so like each cell on that grid represents a geographic location. And this type of representation is good when you're thinking about something like weather, which has movement over the Earth's surface. So the different pixels in the cell can give you information about what's happening in that particular location. And there are two main types of files for spatial data: shapefiles, which is what we'll be looking at today, and also GeoJSON files. So CRS, the coordinate reference system. So this is a framework that is used to measure locations on the earth as coordinates. So the most obvious type of CRS is our geographic coordinates, latitude and longitude, right? You got the grid on the earth, you got these coordinates, and you can find exactly where you are on the Earth's surface. The other type of CRS is projected coordinates, and these are used to flatten the 3D dimensions of the Earth into a 2D representation. And they're particularly helpful for when we want to do like distance calculations and things of that nature. Note is CRS is different for where you are in different parts of the earth. So usually different regions have different CRSs. And this is because the earth is an imperfect sphere, right? So some parts of the earth, the region is mountainous. And so the CRS has to account for the ups and downs of that part of the world. So one thing to remember when you are working with spatial data is that the CRS may be different. And then if you're bringing in separate data sets, you want to be sure that you set the CRS to the same thing so that your data doesn't go wonky. GeoPandas. So it's how we'll be manipulating geospatial data in Python. It allows you to work with data in a manner that's very similar to pandas. If you already know Python, hopefully you know a little bit about it already. It's great for like data frames. And so the power of working in GeoPandas is that all of the functions that it allows you to perform that's similar to working in pandas, but having that spatial component. And one thing to remember about GeoPandas data frame is that each one will have a geometry, and it'll literally be called geometry, and and you need it to be called that so that it can recognize it. And this is basically where you will have your coordinates, where you'll have your specific representations of space in your particular CRS. And that is going to be important when you get into mapping, doing spatial joins. The power there is just like you would merge two normal data frames with GeoPandas data frames, you could actually do a spatial join so that you can start layering data. So one of the things that is very powerful, and I'm going to show you, is, let's say, for instance, we have a data frame that has representations of just of Chicago, like the neighborhoods. So each neighborhood is a shape, a polygon in Chicago representation. And then let's say we have data on crimes, and we have the latitude and longitude of where each crime took place. We can use the different information about the different shapes to overlay them based on that coordinate system, and thus join them so that we'll know all of the crimes that happened within a certain community polygon. So that is kind of the powerful thing around that. And then another powerful thing is being able to create buffers around a geometry. So when I say that in particular, it's basically drawing a radius. So if I wanted to say, I want to know all of the crimes that happened around the Sears Tower, if I have the coordinates for the Sears Tower, you can draw a radius, and then using that new shape, that new polygon you created, you could do some of the same type of intersections and joins to see how many of those crimes are in that area. And one thing to remember about spatial joins is being mindful of that OP parameter in there. And we'll talk more about that when we move over to the notebook. But how you join, whether it's using intersects within or touches, it's basically giving you information about how you want those shapes to be interacting with each other. And that can have a big effect on how the two data frames are joined and what information you actually get back. Okay, so now we're going to move over to the notebook, and there's a lot there, so I'm not going to dig in too deep to every cell because it's very long, but basically you're going to see how to combine spatial and non-spatial data from different sources, how to create maps, how to make a buffer, and then some of the analysis that I worked on. Oh, my screen didn't change. Hold on, let me switch over. Can you, okay. You guys can see my notebook now, hopefully. Yes, okay, cool. All right, so again, I'm gonna assume that you have some familiarity with Python. You know how to import a package, you've seen pandas, etc. Just note here, we're importing GeoPandas as GPD. And now I'll move on to kind of talk about the data. So the data that I used in this analysis, I either got it from Chicago's government websites, or they have a lot of data sets available, or there's an organization called the National Historic GIS. They have a lot of census data in context of in GIS of spatial. So I got data for boundaries for community areas in Chicago. From the NHGS, I got data about census block group levels, because I just felt that it would be more helpful to look at the data at a more granular level than neighborhoods, because as we know, things can change a lot from block to block. And so summarizing by a community area, a neighborhood, might not be giving you the whole picture. And then I also got data for business licenses in Chicago. So any registered business, it was in this data set along with its latitude and longitude of where it is in the city. Crimes along with where they happen. So reported crimes is actually what that is, and arrests. And the CTA, the public transportation L stops, the latitude and longitudinal information for these as well. So the majority of these data sets are CSVs, so you just would read them in for pandas as normal. However, the community areas one, as well as the block group one, are shapefiles, and I mentioned that type before. So we're going to use GPD read file, and if you notice here, the ending is .shp for shape. And basically, like I said, you can do pretty much the same things with a GeoPandas data frame as you can with any other type of data frame. So creating a plot is super easy, normal way. Again, the thing to remember is that GPD data frame is going to have a geometry column that's inherently going to be in a shapefile anyway. And so when you do a plot on this type of object, it is automatically going to use that geometry to make the plot. So just doing the plot here, I just added colors as community and added the labels. You quickly get a plot of Chicago just from reading the file in. Excuse me. Next, I added in the block group information, same way, just to reiterate that it's very easy to do some of the same types of operations on this type of object. So when I read in that block group data frame, it had the column county FYP in it. And that's because this file actually was for all of Illinois. So I found that Chicago's code was 031. So filtered on that just to get the polygons that make up, Cook County, that's a county column. Just make up Cook County. So this map is actually of Cook County. And then another thing that I noticed when I initially mapped this data frame, which you won't see here because I've already filtered it out, but is that this part over here to the right was filled And if you know Chicago, you know that this is actually Lake Michigan right here. So it's a water area. So I just looked for the largest water area in the data set, and then I filtered that out. So giving us a map that wasn't kind of tainted by the view of Lake Michigan. Okay, so the next thing here I want to talk about is doing a spatial join. Like I said, a big part of the focus here is looking at the block group level because it's smaller. However, you want to know what communities these block groups fall into. So here we're going to be joining these two data sets so that we'll know all of the block groups that fall within a specific community. So one of the things that I like to do is quickly make a copy of the geometry in each of the data frames that I'm going to join. Just because, like I said, when you join them, you're only going to have that one column called geometry, and that's going to be your active one. So I do that so I don't lose the information about the other geometries. And also, if I want to switch between the two, it's easy to do it because I already have that information there. And then I talked about the CRS earlier on today, making sure they're the same. So I set the CRSs in the two different data frames to be the same here. And then you can go ahead and do your GPD spatial join, S-join, for the block groups and the community areas. I only needed these 3 columns. It's a left join, just like how you would do on any the pandas, you know. And then I mentioned earlier that OP parameter where intersects is going to probably get you where you need to be for the majority of the time. But like I said, do take some time to, to think about it when you are making spatial joins, and just be sure that that is what's going to be appropriate for what you're trying to do. And you can look at the documentation for more information about that. So after doing this join, we just ran some stats, and this is how many community areas, how many block groups, and then after the join, since we were at the block group level, we still have the length of the data frame is still approximately 4,000. And when we do the plot, we can see that the active geometry is still block groups because they're small partitions rather than larger community areas. And just to show you about how you can switch between the two, this data frame that I joined, I called it Chai. And here I'm just making a copy of the data frame. And as I told you before, I copied the geometries for both of the data frames. So they're in this new frame. And I'm switching the active geometry back to community because right now it's block group, as we saw above. And then when I plot it, the plot is back to the larger community area partitions. Easy peasy. Okay,
Hey,
so
Laura, question
yes.
before you go on. Could you explain again what block group records are?
Yes, it's a census qualification. So it's the lowest level that of data that the census collects for people. So if people, the census collects information about income and race and education and things, they will go down to the census block group level to collect that data. That's the lowest level.
And is that the same thing as like street address?
No, it's not street address. It's larger than street address. It's smaller than zip code. Okay. So it's somewhere in between. It's usually a collection of a couple of blocks.
Yeah, I used to do census collection, and the census blocks are basically kind of like just literally like a few blocks, but they fit within the boundaries of a zip code. So if you have a zip code, then you can very easily fit the census block in there.
Nice. Thank you.
Are they predefined by the census?
I believe so.
Okay. Thank you.
Any other questions before I move on? Okay. So here, you can see we've headlined the three main kind of things that I wanted to look at: transportation, is there stuff to do as represented by business license data, and crime. I am actually not going to open all three of these because time is short and code is long. However, I'm going to walk you through kind of one of these just so you can see the process. So for business license data, if you remember above, it was just a CSV. We read it in, we saved it as BizDF. And as I said before, I'm interested in how many things are there to do around me, particularly restaurants, bars, and cafes is the thing that really interests me. So looking at this data, the business activity qualification in the data set, I just wanted to take a look and see what types of businesses they had and kind of how much of each type. And then I, did a little EDA. I did more, but not in this notebook because that's not the purpose of this. But looking for missing data, you always, when you're doing any type of analysis, take the time, take the steps to like really look at your data, really do the EDA, look for data types, all of that stuff. I'm not going to walk through that here, but one of the things that I noticed with these business activity groups is that there's a lot of them. There are a ton of them. That's not super helpful for what I particularly wanted this for. And like I said, I'm particularly looking at for restaurants, bars, and cafes. Judge me if you want to, but that's what was important to me in this analysis. So I created my own categories, which I did here. I'm not going to walk through that because that's also a whole kind of probably another project in itself. But know that I did do that, and then brought it back here to flipping our data frame, which is just a regular pandas right now, to a GeoPandas data frame. So how do you do that? First, I did a little formatting, obviously, just filtering out to only get city of Chicago and things of that nature. And then when you have a normal pandas data frame, you can call GPD geodata frame, and then you need to specify what your geometry is going to be. So particularly points from XY, if you have your longitude and latitude, you would just place those in this function. You would specify your CRS. Again, I'm making sure that I'm using the same CRS for all of my GeoPandas data frames, and this was specified as what was good for Chicago, so that's why I'm using it. And you can Google that, like, or wherever you're at, you can just Google. And yeah, once I did that, my data frame is now converted to a GeoPandas data frame, and I can map it. So we already had our community level map. It's easy to overlay plots on top of each other. You guys, like I said, you know Python, you can do that in one cell. So now we're just overlaying that Chai data frame map with a map of all the points of business licenses. There's clearly lots of businesses. So that's here just to give us a sanity check of did that play out how we thought, that conversion. Okay, so changing Active Directory to block group, because at this point we crimes was a point. The geometry, active geometry was the point for where a crime was. And now, oh, this is the shy, sorry, I'm jumping ahead of myself. So here is just so you can see how the data frames look. I'm not sure if I've actually shown you any of the data frames yet, but this is the Chicago one. It has the communities. It has that geometry column that I've been talking about. It has the polygon for the community level because I copied them. It has the block group polygons and then some of the other characteristics that were in the data. If you notice here, there are some NANs. Again, when you are joining, when you're doing your data, be mindful of this. These NANs actually come from the fact that the block groups are for Cook County and the communities are only Chicago. So when you do, when I did the join, there are no communities for some of these block groups that are outside of the bounds of Chicago. Eventually what I'll do is drop NAs because I only care about Chicago anyway, and you'll see how that will change the map when we drop the NAs and just get within Chicago and not just Cook County. Okay, so the next thing here is we have our business points. We want to relate that to the map, the SHI map of Chicago. This is where I was jumping ahead. So we're, again, making sure that, you know, our CRSs are correct, and we are going to do another spatial join on our SHI data frame, which gives us, you know, the polygons of our block groups and our communities, with our SHI biz data frame, which the polygons are the points of where the businesses are. And we're gonna do a right join here because we want that every point is associated with a block group. So once we do that and just kind of clean up the data, the outcome of that is this data frame here, where the point, this is how you know it's our businesses because the geometry is a point and not a polygon. The point is the active geometry. The data frame is very large. There's 50,000 points or businesses. And then we can still see here that we've retained our geometric information for block group and community area, as well as the other characteristics from that as well. Okay, so the next kind of important thing we'll do, which is key to joining all of this data together eventually, is right now we have all of the points and their associated geographies within block groups. However, for this analysis, it's going to be way more helpful to summarize what's happening in our block groups. So we're going to want to make this data aggregated. So the first thing is simply doing a group by and then doing a count for how many businesses are within a block group. And I also wanted to see by category, again, because there were so many different ones and I'm only concerned with certain ones. So grouping by the block group as well as by the business category, and then counting how many businesses within each. And then once I got that kind of aggregated information, I pivoted the data frame to make it wide. Why? So that we can bring this back to the block group level, so that when we decide to, you know, start summarizing our block groups based off of these different characteristics, every block group is a row, and we will have all of our characteristics as columns. So that's what we're doing here, pivoting our business data that we aggregated here with this group by. And the resulting data frame is this, where we have our geometry, which is a polygon once again, and we have our different business categories and the counts for each of them. And we can, again, whip out the plots. This is just an example of coloring this plot by one of our characteristics. So the count of restaurants, cafes, we can see how that looks on the map. It's kind of hard to tell because it's such a granular level, but you can see that, you can see that a lot of the high concentrations of dining and bar experiences are more around the Loop, near North Side, near West Side area. All right, so like I said, I did something very similar for both crimes and for CTA. So I'm not gonna walk through, those. I'm gonna keep going. The next thing is actually combining the data sets. So I'm just gonna kind of show you what they look like. We have our Chicago Shy data set, which has our boundaries for both Black group and community. We have our CTA, which I didn't show you, but it's at the Black group level, and it has a count of all of the CTA L stations in that Black group. And then we have the business data frame that I showed you, which is also at the Black group level. And then we have a crime one, which with specific types of crimes, their counts, and the specific arrests and their counts at the Black group level. So now that we have all of these data sets at the same level, we actually don't need to do a spatial join to join them because they're all the exact same polygons. And one thing that I neglected to mention is that when you start doing operations like group by, you actually cannot group by a geometry type. So I had to convert those anyway from a geometry to a string to do those operations. So they're already ready to be just do a normal join. So that's what I'm going to do here, joining the Chicago data with the CTA data, then with the business data, then with the crime, just a normal merge, and all on the Block group level geometry string. And let me pause to say, I think I've seen questions pop up, but I'm not going to answer them right now because I want to get through this, and like I said, time is short. But I will try to get to questions at the end, so please be patient with me. Okay, so we have our data merged into a frame. I'm going to talk a little bit about just the analysis steps. So some of this is backtracking, but I created a new feature. It's for arrest rate. And I added that into our data frame, and just do a quick correlation plot. A quick correlation plot just to show quickly, you know, what relations there are happening within the data. You know, some of the things that we had already saw, right? Like thefts happening more around where there are food establishments, and also L lines, L station counts also have that correlation with restaurant and bar density. With crime, narcotics is one of the only crimes that's almost perfectly correlated with number of arrests. Not sure what that means exactly. Perhaps, you know, police focus more on this particular type of crime, so they make more arrests. I don't know. Interesting stuff, though. Violent crimes and violent crime arrests also have a strong linear relationship, which kind of tells me that these things may be in step, like the police are making more arrests for these types of crimes as well. I did a quick scatter plot matrix. We all know correlations in and of themselves can be misleading, so always nice to just look closer at the plots to see if the relationships are kind of what the correlations are saying they are. And then just looking at some different distributions. Again, I'm not gonna spend too much time on this because I do want to talk to you guys about buffering. But yeah, when you're doing analysis, it's good to see. So this data is at the block group level. So each one of these points in these box plots is a block group. So it's good to see kind of how much variance is happening between block groups for these particular features, whether it be for crime or, and see, we have some big outliers here for some of these, or whether it be for arrest rates. Some more distribution type things here. I did a lot of histograms just by kind of looping through our different characteristics. You know, most block groups have very few businesses. That's why the category closest to 0, there's usually a huge spike. But there are some block groups that kind of have a overinflated amount of the particular features. So just something to note. Now let's go to looking at place. So I wanted to particularly look at certain things. So I just made a list of features that I wanted to plot on and just look through making plots for these using a for loop and colored them by the feature. So you can see here, we've seen this one a lot, restaurant, bar, cafe, but beauty establishments. So interestingly enough, they're all over the city. So no no biases there with you know, beauty related establishments. Theft, again, concentrated more where like the stuff is happening. Arrest rates for theft is kind of more, you know, more distributed. Violent crime, interestingly enough, seems to be more, you know, south of, this is like the loop, so more south of the loop. Anybody who knows Chicago, that's not a huge surprise. And west and south, which I mentioned, I think, in the beginning. So yeah, these are the kind of insights you can get from just kind of looking at the maps. And then I switched my geometry. That's why I like keeping them in the same data frame, because it's hard looking at those maps at the block group level, right? Those things are tiny. Let's get some aggregate summaries of what's happening here. So I redid the maps, but at the community area level. So it's just a lot easier. Just a quick, obviously I had to aggregate. So I did a group by and summed the kind of straightforward features and took the averages of the rates. And so that's what you see on these maps, a summation or average if it's a rate. Now you can clearly see that the north side is winning when it comes to restaurants and bars, cafes, as compared to the rest of the city. You can get a clearer picture of what's happening with beauty. Like, yeah, it's all over, but you know, still it's up there. One interesting thing, if you know Chicago, you know that this is actually Austin. It is one of the violent neighborhoods in the city, and oddly enough, it has a lot of beauty beauty establishments. So that's interesting to me. Yeah, so other things that you can just kind of see more clearly when you aggregate the data up. One thing I did later, which I wish I had done in this presentation, is to create these maps in Plotly, because it actually has a hovering feature where you can hover over the data and see the features, like the numbers, and you could see the names of the communities pop up. So if you are doing this type of analysis, now see, as you keep going, you learn more stuff. I would have used Plotly to show you guys that, and I highly recommend because it's easier for spatial. Okay. Bar plots are good for seeing rankings of communities, since we're talking about community areas. So we can see who has the highest theft, the loop, we already know that. Beauty, what else we got? Restaurants, we can see all of these things. Violent crime, Garfield Park, that's on the west side. So yeah, simple things that you can do now that we kind of merged all these data sets together, that you can get insights about as far as from a spatial lens. So let's talk about buffers. So I mentioned creating a radius around a point so that you can make some insights about what's happening around that particular point. So one thing to note is that when you are doing distance measures, as I said before, you usually want to use a projected CRS type. So we'll be switching all of our data frames to a projected CRS. Another thing is that those distances and things are usually in meters. So I made a quick function to translate meters to miles because we're American. And oops. And so now we have our data frames as projected data frames. And we have our CTA, our businesses, and our crime. The use case I was interested in was kind of understanding how many businesses and crimes are happening within a certain radius of a CTA L station, since living close to a L station is important to me. And the buffer that I chose to create is a half-mile buffer, because I think it takes about 10 minutes to walk half a mile. So yeah, I just used half a mile. This comment to actually create so X is the buffer. That's just drawing the circular polygons around the CTA point. So that's what X is. This code here that I've commented out is actually so that you can look at both the crime data frame and the business data frame and return just points that are within any of those buffer polygons. But I've commented it out because it took a while to run. So I'm gonna do that. But it's pretty straightforward. Again, you have two polygons and you're looking at intersections of the two shapes, polygons or points. Okay, so I saved those that code as CSVs because I didn't want to have to run it again. But after converting them back to GeoPandas, this is what that data looks like, those computations to get those buffer points. So what you have is the geometry of the buffer, which is a polygon. It should be a perfect circle. And then you have, this is the business one. So you have any point that is within those particular polygons, buffers, and the same for crime. And here, just to do a sanity check, I plotted our in-buffer points. Orange, I showed you on one other map, the CTA L station. So orange is CTA L stations, and we've overlaid the in-buffer points for businesses. So you can see that they track to the L. So clearly our in-buffer radius transformations, they worked because those points are where we expect them to be. Okay, so I think those are the main important things. Oh, so I showed you the points. Now, some of these plots here are just summarizing some of that in buffer points for the CTA. So here we have a map of the CTA L state, but I've colored the points based off of the density of businesses around that were in that buffer. So you can see here, this is for restaurants, bars, and cafes, that these are the stations that have high density of those. These are the L stations that have that. Even more interesting to me was looking at violent type crimes. So here I can quickly see which L stations have a lot of violent type crimes within a half-mile radius. So when I'm thinking about where to live and I'm like, oh, I want to live next to the L, maybe these stations in particular are ones I don't want to live next to. So yeah, that is basically it. And I am so happy to see that I got through this presentation in time. Like I said, this is part of a larger project that I'm building an app to actually take all this information, have filters, be able to play with everything and see all of this stuff on an interactive app. And the next steps will be, I've done it already, it's just not ready for consumption, but adding in demographic area, race, and income. Chicago is one of the most segregated cities in the country, and there are some very interesting maps that I've made to show how race is distributed in the city and how that correlates with how income is distributed in the city. And I also built a script to scrape apartment listings from realtor.com, so that, you know, you got to have it be in budget when you're thinking about where to live, so we can get average rental prices in these block group areas to see, you know, is this a place that I could live? So hopefully I can do another presentation where I can show you guys the app and some of the interesting things there. Let me turn to the chat and see if I got some questions. Feel free to unmute and ask me a question too if you want to do that. That might be easier.
Lauren, I have a quick question. This was a great presentation. Thank you. I needed to step up my dissertation per one of my committee members. And I'm going to start with this code that you've already outlined. Thank you very much.
Use it.
So my question is, I'm looking at nonprofits though, when it comes to businesses. It didn't look like any of the businesses that were in your data frame were nonprofits. Do you know if there's some segregation of nonprofits versus for-profit businesses?
Oh, that's very interesting. I actually don't remember seeing nonprofits in that data set now that you say something. So maybe it's a different type of license. Maybe it's a different data set. That's interesting, Kim. I don't remember seeing nonprofits in that data set.
Okay, I will look into that and thank you.
Mm-hmm. Sia, I see you.
Hello. I came back as myself. I wanted to ask this for Jessica. Is it Jessica? Please correct me. I think it was Jessica.
I am. Hi.
Hi. Was asking about where you find data sets with space files or GeoJSON files. I don't know if it was just space files that you were looking for, but I remember that.
Just a general repository of these kinds of maps, of these kinds of geography definitions. So the dot shape and the dot GeoJSON, those are defining boundaries or polygons. And so I was wondering, like, if there were some good places to get those, you know, like a repository, because I mean, like, boundaries are being redrawn all the time, especially in, you know, like places like cities or things, you know, like that are kind of subjective. You know, like, oh, I wonder where my neighborhood in Seattle ends and where the next one begins. And there's like, I don't know, local fighting over, no, it's at 15th Street, no, it's at 12th Street, like that sort of thing.
Yeah, that's an interesting question. And I think that's one of the big challenges with making a unified analysis about things that happen across the US is because every place does something different. You really have to go to the local level when you're looking at data, unfortunately, because everyone stores the data differently. I know for Chicago in particular, like you said, even those community areas, they change those files. Like communities change all the time. So the most recent one that I grabbed is a bit different from some of the older ones. So you really have to look locally and see what they have as far as the data. Thanks for your question. George said, does your crime database include location of police monitored CCTV around the city? This particular data set did not have CCTV. I would bet Baltimore also has a data push, just like many other kind of bigger cities in the US. And there are tons of data sets. Seriously, like you could spend a lot of time, at least for Chicago, like scrolling through. So again, I would encourage you to look up Baltimore and see what they have, because like there's all types of random data out there.
I have one last question, that if other people don't have one. Do you know if this works on a smaller scale? Because I know that, like we're covering big swaths of, locations like a city or, like a county or even a state. But, like when I think about like more micro applications of this, it stands to reason that it should actually scale down as well, like these kinds of, like to maybe a drawing or something of that nature, like that way, like if you're doing a digital twin or something like that, like you can say, okay, this machine has, like this flowing in and out of it. And then that way you can actually have a visual representation of where work is within, like a certain factory process or something like that. And so that's one thing that I was like, okay, well, clearly you would have to define your own, boundaries, but have you ever heard of anyone having that kind of a use case before?
Yeah, no, I have not. But actually, what you were saying made me think of raster data, which I don't know anything about, so I'm not going to pretend that I do. The only thing that I know is, like I said, it can capture movement more so because it is grid based. And so I'm not sure how granular. I mean, I'm sure anything is possible. It's just at how granular is your data, right? And since we know that in the instance of, at least for vector data, we get down to the point, right? We get down to longs. I'm sure it's possible. Interesting use case. I've never heard anything like that.
This is a great presentation. Thank you, guys.
Thank you. So are there any more questions? If not, I just wanted to follow up by saying there will be a survey that'll come out, and I encourage you all to take the survey because we want to continue to bring you guys more content that you want to hear that's helpful. I'm always looking to improve. This is actually the first technical talk that I've given. So definitely feedback is welcome, just to make sure that you're having something that is interesting and that is valuable to you. So please do fill out that survey.
We'd like to thank everyone for attending today, and we invite you to visit us on our socials. We are on LinkedIn, GitHub, YouTube, and Twitter. You can also email us at contact@blacktidesdata.com. Once again, we thank you for your support. Yours in data, Black Tides.